Language is one of the oldest tools we have. It is how we share ideas. It is how we build relationships. It is how we pass knowledge from one generation to the next. For most of human history, only people could use language. Only people could speak. Only people could write. But today, something new has arrived. A machine that can write. A machine that can explain. A machine that can translate. A machine that can hold a conversation that feels natural. We call it a large language model. But the name does not reveal what it really is. Inside this system, there is no mind. There is no awareness. There is no understanding of the world. Instead, there is a structure made of numbers. A structure trained on human language until it can mirror the patterns we use every day. This machine does not think. It predicts. It does not understand. It imitates. And yet, the result feels intelligent. It feels alive. It feels like something that understands us. Today, we open the black box. We explore what an LLM really is. We explore how it learns. We explore how it generates language. And we explore why it feels so human. This is the story of the machine that learned to speak. A large language model is a type of artificial intelligence built to work with language. It can read text. It can analyze text. And it can generate new text. But it does not understand language the way humans do. Humans learn language through experience. We connect words to emotions. We connect words to memories. We connect words to the physical world. An LLM learns language through patterns. It learns by predicting the next piece of text. At its core, an LLM is a giant mathematical function. You give it text. It predicts what comes next. That is the entire mechanism. Prediction. But the scale is what makes it powerful. Modern LLMs have billions of parameters. They are trained on trillions of words. They run on massive clusters of GPUs. This scale allows the model to capture patterns that are too complex for any human to notice. It does not understand. It recognizes patterns. And those patterns create the illusion of intelligence. An LLM is a digital echo of human language. It reflects the structure of everything it has read. Before an LLM can process language, it must break it into small pieces called tokens. A token can be a full word. It can be half a word. It can be a punctuation mark. It can even be a single character. The model does not see sentences. It does not see meaning. It sees a list of token IDs. Each token is just a number. Imagine taking a book and cutting it into tiny pieces. The model never sees the full page. It only sees the pieces. This process is called tokenization. It defines the vocabulary of the model. A model with 50,000 tokens has 50,000 building blocks for all language. When you type a sentence, the model converts it into numbers. Those numbers go into the neural network. And the network begins its work. Tokens are the atoms. Everything else is structure. Tokens by themselves have no meaning. So the model transforms them into embeddings. An embedding is a vector. It is a list of numbers that represents meaning. Imagine a huge space with many dimensions. Every word becomes a point in that space. Words with similar meanings appear close to each other. Cat is close to kitten. Doctor is close to nurse. Run is close to running. The model does not understand these concepts. The math simply places them near each other. Embeddings capture relationships like gender. They capture tense. They capture geography. They capture analogies. This is why the famous equation works. King minus man plus woman equals queen. Not because the model knows what a king is, but because the geometry of the embedding space encodes the relationship. Embeddings are the first layer of intelligence inside an LLM. They are a mathematical shadow of meaning. Inside every modern LLM is a structure called a transformer. This architecture changed everything. The transformer is built from stack layers. Some models have dozens of layers. Some have hundreds. Each layer has two main parts: self-attention and feed-forward networks. Self-attention. Self-attention allows the model to look at all tokens at the same time. It helps the model decide which tokens matter to each other. In the sentence, the cat that chased the mouse was hungry. Self-attention helps the model connect cat with was hungry, not mouse. It is like giving the model a spotlight. The spotlight highlights the important parts of the sentence. Each layer has many attention heads. Each head focuses on a different pattern. Some heads track grammar. Some track long-range connections. Some track tone. Feed-forward networks. After attention highlights what matters, feed-forward layers transform the information. They compress it. They expand it. They reshape it. Each layer refines the model's internal understanding. When you stack many layers, the model becomes capable of capturing very complex patterns. The transformer is the engine. Parameters are the weights inside the neural network. They are the numbers that store everything the model has learned. During training, the model sees billions of examples. Each example adjusts the parameters a tiny bit. Over time, these small adjustments become knowledge. But this knowledge is not stored like a database. There are no files. There are no sentences. There are no facts written down. The model stores patterns. It learns how sentences flow. It learns how ideas connect. It learns how questions are answered. It learns how stories are structured. It learns how code is written. The parameters encode the shape of language. This is why LLMs can generate new sentences they have never seen before. They do not memorize. They generalize. Training an LLM is one of the most expensive processes in modern computing. The model is shown text from books, text from articles, text from code, text from conversations. The training loop is simple. Show the model a sequence of tokens. Hide the next token. Ask the model to predict it. Compare the prediction to the real answer. Adjust the parameters. Repeat billions of times. This is called self-supervised learning. The model learns grammar. It learns reasoning patterns. It learns writing styles. It learns world knowledge, all from predicting the next token. It does not understand the world. It understands patterns in text about the world. When you type a prompt, the model does not search the internet. It does not look up answers. It performs one operation. It predicts the next token. Then it predicts the next one, and the next one, and the next one. Each prediction depends on the input. It depends on the parameters. It depends on the context window. It depends on the probability distribution of possible next tokens. This is how the model writes essays. This is how it writes poems. This is how it writes code. This is how it explains ideas. It is not recalling. It is predicting. The illusion of intelligence comes from the depth of the patterns the model has learned. LLMs do not have long-term memory. They only see what is inside the context window. If the window is 8,000 tokens, the model can only consider that much text. If the window is 200,000 tokens, it can consider entire books. Everything outside the window is forgotten. This is why long conversations sometimes lose coherence. The early parts fall out of the window. The context window is the working memory of the model. It defines how much the model can handle at once. LLMs are powerful, but they have clear limitations. They do not understand meaning. They do not have beliefs. They do not have desires. They can hallucinate incorrect information. They cannot access real-time data unless connected to tools. They do not know anything outside their training data. They cannot verify truth. They cannot reason like humans. They are pattern machines, not digital humans. Understanding these limits is essential for using them responsibly. If LLMs do not understand, why do they feel so human? Because language is a pattern, and humans express thoughts through patterns. When an LLM learns the patterns of language, it learns the patterns of us. It reflects our writing. It reflects our logic. It reflects our creativity. It even reflects our flaws. This is why interacting with an LLM feels like interacting with a mind, even though no mind is present. The intelligence you feel is not inside the model. It is inside the patterns it has learned from millions of human voices. When we look inside a large language model, we do not find a mind. We do not find memories. We do not find understanding. We find math. We find patterns. We find billions of parameters arranged into a structure that reflects human language. And yet, from that structure, something remarkable emerges. A machine that can communicate with us. A machine that can assist us. A machine that can inspire us. Not because it understands the world, but because it has absorbed the patterns of how we describe the world. An LLM is not a digital brain. It is an echo of the books we wrote, an echo of the conversations we had, an echo of the ideas we explored. It is a mirror shaped by data, a mirror that reflects the collective knowledge of humanity. As these models grow, one truth becomes clear. Their power comes from what we teach them, not from what they are. Understanding how they work is the first step toward using them wisely. This is what lives inside an LLM, a mathematical echo of human knowledge, and a glimpse into the future of how we will build, learn, and communicate. Thanks for watching, and I'll see you in the next chapter of this digital adventure.